So today we'll discuss about the single phase induction motor. As you know that already you might have heard the name induction motor and the classification of electrical machines based on the supply, AC supply and the DC supply. We have so many machines are clearly classified. In that AC machines, based on AC we have two supplies, single phase AC supply and three phase AC supply, and all the AC machines which are rotating and non-rotating, that is static machines are there. So today we will discuss about the machine which is operating based on the single phase supply only, right? That is what we call it as a single phase induction motor, right? So generally where we are applying this, using this three phase single phase induction motors, generally in a environment, outside world, we used to see everywhere we come across the single phase induction motor. For example, whatever the fan we are using, right, that we convert electrical energy into kinetic energy by the use of a single phase induction motor, right? And the motors which we are using in your households for pumping of the water from ground level to top level, that is also a single phase induction motor. Why there we are using single phase induction motor? Why? Because we don't have a three-phase supply to our households. Only single phase supply is available to our households. If you could have a three-phase supply, then we can go for a three-phase induction motor, right? So three-phase induction motor is having a more advantages than the single-phase induction motor, though. But the supply available to our households is only single phase. That is why we are going for the single phase induction motor. So you can see what are the different applications of single phase induction motor everywhere. Washing machine, refrigerator, blower, everything, fan, right? Grinding machines, kitchen also, kitchenware, so many kitchenwares are now available, all are using the single phase induction motor only, right? So as the single phase induction motor, we have a different types are there, induction motor, synchronous motor, commutator motor, different types are there, both all are applicable with the use of single phase supply only, right? So as far as the single phase induction motor is concerned, this working of single phase induction motor, construction of single phase induction motor is similar to three phase induction motor, right? So coming to the construction, so as we all know, the rotating machine, there is a rotating machine, we have two main parts. What are the two main parts? Stator and rotor. So stator consisting of a static winding, rotor consisting of a rotating winding, right? So in three phase induction motor, just for a glance we can recall the three phase induction motor, where if you apply three phase supply to the three phase stator winding, then what happens? A rotating magnetic field will be created. That rotating magnetic field will cut the static rotor conductors so that EMF will be induced in the rotor. If the rotor is short circuited, then the current will produce, right? That current will flow through the circuit so that the torque will be produced. Due to that torque, the three phase induction motor is a rotating, right? But as far as compared to single phase induction motor, construction is same. We have two windings, stator winding and rotor winding, but only the difference is here we have only one winding. As we are saying, this is a single phase induction motor, only one winding will be there, right? So one stator, one winding will be there, and rotor may be construction of one, depends on number of poles, similar to our rotor construction of three phase induction motor, right? Like 2 pole, 4 pole, 6 pole, 8 pole. Because why this pole concept is coming is the speed of the machine will depends on the number of poles and the number of the value of frequency also. Though the frequency is constant as far as India is concerned, 50 Hz. So the speed of the machine will depends on the number of poles, right? Ns is equal to 120 F by P, where P is the number of poles, right? P is equal to 2, 3000, P equal to 4, 1500 RPM, P equal to 6000 RPM, and so on. So the rotor construction can be similar to the three phase induction motor construction, whereas the number of poles can be multiple of even number, 2, 4, 6, 8, 10, 12 and so on, right. Now coming to the single phase induction motor working principle. So just we'll have a look at single phase induction motor. As you are saying, it is a single phase induction motor, only one winding is there. You are applying a single phase supply to the machine, right. When you apply a single phase supply to the machine, one alternating current will flow, right. So with respect to T maximum voltage, at each and every instant we have one particular value, right. So if let us say at T1 some magnitude will be there, another T2 some magnitude is there, another time T3 some magnitude is there. So here as far as time is concerned, magnitude is varying high to low through 0, right. But it is not a rotating magnetic field, it is a alternating field. Say there is a difference between rotating field and alternating field, right. This is alternating field, but rotating field is a invisible thing which is a resultant of more than two fields, right, more than two, maybe 2 or 3 fields, right. If you concern 3-phase induction motor, we have 3 fields, first, second and third. 3 fields will be there, let us say A, B, C. 3 windings are there, so 3 fields will be there. So 3 fields are there means resultant will be 1, right. That resultant can be any value. Generally the resultant flux is equal to 3 by 2 phi m, 1.5 times of the phi m. But you will not get this value it will be an invisible thing which is a rotating resultant of these 3, right. But with one phase, how can you get the resultant? How can you get the revolving? We cannot, right. So that is why in order to start the single phase induction motor, we should have a certain arrangement should be made, right. So this is what I have explained so far. So stator is there. This is your stator. Rotor is there, right. Let us say north pole, south pole. Stator winding is there. Here you will give a single phase supply, right. When you give a single phase supply, you can find from the thumb rule, right hand thumb rule, from the current direction you can find the flux direction also. Let us say the current is like this, right. So current is flowing like this. So current is flowing like this. So flux will be north to south, right. Now assume some conductors on the rotor conductors, and let us take the current direction. It is towards you, this side, right hand side, left hand side it is into the board, right. So what happens? The current is coming your side. So somehow like this, current is coming towards and entering into the board like this. So flux direction will be like this. So let us say represent this is phi r and this is phi s. S stands for stator, R stands for rotor. So stator flux is horizontal, rotor flux is vertical. So you have 2 fluxes, right. So the resultant of this will be used to produce torque, so that the induction motor, single phase induction motor will be rotated, right. But if here what we are discussing, if you have only one supply, only one flux will be there. This flux is available when the rotor rotates. When the rotor rotates, then only this flux will be there. But at the time of starting, what happens? We have only one single phase flux, right. That is phi s is only available, phi r is not available, right. But in order to make the induction motor rotates, phi r to be produced, right. How we can produce the phi r, right. That is called as a phase splitting. So for this we have two theories are there. The first one is called as a double revolving theory and second is called as a cross field theory. In the first one, here I can show you the diagram. See this one. The equation for the alternating magnetic flux whose axis is given by let us say B of alpha is given by B max sin omega t cos alpha, right? And whereas B max is your maximum flux density of the sinusoidal wave what you are giving, right? And sin omega t AC component B max sin omega t. Cos alpha, alpha is the variable component because whatever flux we are getting, the B of alpha, that will be resolved into two components, right? Like salient pole machine. One is the D axis, another is Q axis. The angle between these two we are taking as a alpha. That is your cos alpha. So that what we can produce is, with this we can produce two components. One will be rotating in a forward direction, another will be rotating in the reverse direction. So that forward direction and reverse direction can be derived with that equation. The first term, see that equation is again this equation. See from the trigonometry you can find out sin omega t cos alpha can be reversed into sin A minus B plus sin A plus B. So if you divide that two components, so you will get the equation as 1 by 2 B max sin omega t minus alpha, which is a forward field, 1 by 2 B max sin omega t plus alpha, that is a reverse field. So when these two fields are available, then the resultant will be there somewhat, so that torque will be produced and the induction motor will be rotated, right? Now cross field. Cross field means whatever is explained here, that is the cross field, right? So the phi s, two fluxes are there, phi s and phi r. Phi s is due to the stator, phi r is due to the rotor. So when these two fluxes are there, then only the resultant flux can be available. If one is absent, the resultant is phi s only. So no revolving field can be obtained. Now in this revolving field theory, the first and foremost condition is run. Run means the machine should be in the running condition. That means by external means you should give some extra force to, so that the rotor rotates, right? Then only the phi r will be available. If you don't give external force, then phi r will not be available, right? So that is why this cross field theory have one assumption, that is one disadvantage we can say, that initially the rotor should be rotated by with the help of a prime mover, extra prime mover. Then only the phi r will be there, and so that you can find the resultant flux which can be revolved in the space, so that the torque can be produced, thereby the induction motor will rotate, right? Now, so as we are saying that here we need two fluxes, phi s and phi r. So we need two we have so many types of induction motors are there. So here I am having, so the first one is as we are saying that one winding is splitted into two, right? So that is why the basic we can say it as a splitting, phase splitting motors we can say. Sometimes the single phase induction motors is also called as phase splitting motors, right? Why we are calling phase splitting motors is one phase is splitting into two at the time of starting. That you should mention. At the time of starting, one phase is going to split into two phases. Though it is a single phase induction motor, two phases are available, but one phase will be cut off after starting, right? At the beginning of the starting, two phases are available. After starting, one phase will be cut off and the motor will run with the help of only one phase only, right? So that is why the first one, phase split motor or resistance start motor. Second is capacitor start motor. Third, capacitor start, capacitor run. Fourth is permanent split capacitor, and the last one is shaded pole motor. So we have a 5 different types of single phase induction motors we have, right? So each and every one we have an application, right? The fan, whatever fan we are using, that is a capacitor start and capacitor run. One capacitor will be there in the fan, right? The capacitor will be used for starting purpose as well as running purpose also, right? And the pump, for pumping the water from ground level to high level, the motor whatever we are using, that is also a capacitor start, capacitor run, right? But in industrial purposes we can go for capacitor start motor. That means at the time of starting only capacitor will be there. After starting, capacitor will be disconnected, right? So split phase, how we can split phase? Because the basic concept will be there, right? So if you have a resistance, what is the phase angle between V and I? Phase angle between V and I is 0. Suppose if you include a capacitor in this, what happens? What is the phase angle between V and I now? It will be less than 90, not 90 exactly, it will be 0 to 90, right? So the I value will be like this. So 90 will be there. Let us say the theta will be less than 90 degrees, right? So that is what the capacitor split. So all the types of single phase induction motor except shaded pole can be considered as phase split motors, right? And we can say, so coming to the first one, split phase motor. Simple, this is the basic single phase induction motor where we have 2 windings. The first winding is called as main winding and second winding is called as a start winding, or you can say it is a auxiliary winding, or we can say it is a auxiliary winding. See here, one switch is there, switch S, right? So generally this is a centrifugal switch. It is a centrifugal switch. So at the time of starting this will be closed. At starting S is closed. If you close S, what happens? 2 windings will be in circuit, right? When you give single phase AC supply, 2 fields will be created. One is main field phi m, another is auxiliary field, that is phi a. So resultant of phi a and phi m will be phi r, right? So phi r can be resultant of phi m plus phi a, phasor difference, phasor equivalent. So that this phi r will be resolved into the air gap between stator and rotor, so that the torque will be produced in the rotor, thereby the rotor starts rotating. As soon as the rotor started, if the machine gets around 50% of its rated speed, automatically the switch will be open. So when the switch is open, what happens? The start winding will be out of the circuit. Only main winding will be there in the circuit, right? So this is what we called as a split phase motor. No capacitor will be there, only 2 windings will be there, where main winding and start winding. At the beginning of the starting, this S is closed. Once the machine started, S will be opened, so that the start winding will be out of the circuit, only main winding will be in the circuit, right? So this is a kind of switch, depends on the speed of the motor, right? So when the machine attains some speed, automatically the switch will be opened. If the speed is 0, the switch will be closed. That is the automatic switch. It is called as a centrifugal switch. At the speed 0, the switch is closed. At certain speed, the switch will be automatically opens. That is what we called as the first one, split phase motor. And second, capacitor start. So in the same diagram, we can enter or we can include a capacitor, right? So that is what we called as capacitor start motor, where the capacitor is connected in the start winding, not in the main winding. So now what happens? The resultant flux in between the main field winding and the start winding will be exactly 90 degrees, right? So this phase angle, voltage, current, the angle between this V and I can be made exactly 90 degrees by putting a C, right? But in practice, C is also having R, right? Due to this R and C combinations, this 90 degrees will not be exactly 90, it will be less than 90, right? So that is why we should consider this start winding also a very less resistance, because if R is increasing, what happens? This angle will also be decreases. So that is why whatever start winding we are taking, that should be of very low resistance, high inductance, right? So that is why the same operation will be there. So when you are placed a capacitor here, the angle between the two fields phi m, this is phi m, and the start winding or auxiliary winding phi a. So resultant will be phi r, right? And both the fluxes as 90 degrees apart, you can find out at every time, you can find out the equivalent flux which will be rotated. Suppose let us take one reference value. Let us say this is main field flux, right? As the capacitor is connected in start winding, what happens? The flux which is produced by the start winding will lead the main winding because of capacitor, right? So this is phi m, this is phi a, auxiliary flux, main flux. So at every stage, let us say at this particular point, what happens? Main field flux is 0. Auxiliary flux is having some value, right? At this particular point, phi a is 0, phi m is maximum. At this particular point, phi a is having some value, phi m will be 0. Like that, at every particular point, one value will become 0 and another value will be available, so that the resultant can be obtained. Every instant the resultant will be there, that will be rotates with the direction, either clockwise direction or anti-clockwise direction. That depends on how we are connected this main and start winding and main winding. Capacitor start and capacitor run. So here we have two capacitors are there. One capacitor is for starting, another capacitor is for running, right? So you can easily obtain from the diagram which capacitor is for which purpose, because the capacitor which is connected in series with the switch, that is the capacitor which is used for the starting purpose, right? So this is for CS, start, CR, run, right? So two capacitors are there. If the switch is closed, the net capacitance will be there, because these two capacitors are in parallel, right? So net capacitance value will be there. Again the same circuit will be there. That means the two fluxes which are obtaining in the main field and starting winding field will be 90 degrees apart, so that you can find the resultant field which will be rotating in the space. Permanent capacitor. Only one capacitor will be there, that will be connected in the circuit. It is a permanent. That means whatever examples I told, like fan and whatever machine we are using in the households, right? Those are all comes under this category, permanent split capacitor type motor. So it has two windings, stator winding, that is the main winding, and start winding. One capacitor is included in series with the start winding, so that you can get the required angle between the two fluxes. And these are the different applications where we can use all this capacitor start, fans, blowers and all, right? Air conditioners, refrigerators and also office machinery and all. Okay. Next, shaded pole. Actually, this is a different kind of single phase induction motor where we don't use this capacitor. We don't use this capacitor, right? It is a similar kind of machine which is useful along with the synchronous machine, because we all know that what are the different types of synchronous machine. Depends on the rotor construction, we can classify into two types, cylindrical and salient, right? The salient pole type synchronous motor is called as a shaded pole induction motor, right? The two poles of the induction motor will be in the form of a salient one, right? So there will be some shading arrangement will be there so that the flux or the angle between the two fluxes, main field and auxiliary flux, will be exactly 90 degrees. That shading will be there. So you can find that copper ring shaded portion of pole, it is arranged so that you can get the required angle, so that you can get the revolving field in the air gap between the stator and rotor of the induction motor, right?